Hello again folks, tonight's video is a mailbag video, or as I like to call it, and I'm pretty sure I've mentioned this before, a what have you been buying now video, as that's what my good lady says every time I get a package delivered. Anyway, does anybody else get that actually? Just me? Anyway, comments down below if you get that from your better half. Yeah, onto the package. It was entirely expected, that's to say it was not unexpected, and as expected, it came from the unexpected maker, Seon. What Seon's created is a modular display kit. And actually, at this point, I will say that I'll probably say display quite a lot throughout this video, so please bear with me. Yeah, what he's created is a modular display kit based on a 7-segment LED display. The PCB is actually the shape of a 7-segment LED display and is populated with WS2812B addressable LEDs, or NeoPixels, whatever you want to call them. So I purchased these from his Tindy store. Of course, I'll link to his Tindy store in the description down below. And of course, his YouTube channel, if you haven't already checked him out, I'd recommend that you do so. And of course, subscribe if you like what you see. Really good channel, and I thoroughly enjoy watching him. And he does regular live streams and all that good stuff. And indeed, this actual kit was designed whilst in a live stream, and he took on suggestions from the boys and girls that were watching it. So it was really good. Nice guy. Yeah, go and check him out. Okie dokes, but let's have a look at it and see what it's like. And if we've got time, we might actually build one in this video. I have already opened it, I just didn't know if there was anything inside. So I'll pop the envelope to one side. And yeah, we get our displays. I ordered 5 from him. And it does come in 2 versions. It comes, well, it comes, I don't know how many variants you could actually have, but it's got, it comes in either kit version or an assembled version, and also either white or black LEDs, so you can just see the NeoPixel through there. It's got a white surround. The black version has a black surround, so you actually only really see the lens. But yeah, I went for the white version. So we'll have a look at them and see what they're like. Now these are, the kit version for UK viewers is I think around £7, and the assembled version is just over £11, I think. However, when I bring this out the package, I will show you that Seon has actually kindly made it open hardware, and he has provided the Gerber files, etc. So if you do want to get the boards fabbed yourself, you can do. However, you know, he's doing this himself, and you know, they're not a huge cost, and it's a nice quality board, as you can see. So I'd recommend you support Seon and buy through his Tindy store, because he's put a lot of time and effort into this. But there we go, there's the PCB, nice black PCB with silkscreen. You can see this is revision 2, well, 2018 revision 2, and main differences from the one that he designed on the live stream is that the header pads, where it's a 45-degree angle to the board, he's made those vertical now, and he's actually changed. There was a sort of nub that stuck out the side here, but he's changed that and put I think it's an SK, what do you call it, 6812, I'm going to say. Yeah, it's a smaller addressable LED down at the bottom right to be used as a decimal point if you wish to do so. So yeah, nice little PCB. I think it's around 7 centimeters by 5 centimeters, something like that. So when you've got a few of them stacked together, you're going to get a nice display that you can, you know, put whatever you want on it, be it a YouTube subscriber counter, you know, something as simple as a clock, whatever you want to do with it, of course you can do. And yeah, it's a 7-segment display, so you could use some basic text if it fits in within the display parameters or layout, if that makes sense. So here's our 2812s. We get 28 of these packed in the strips. Little bit of silica there to keep it nice and dry. We get our caps. I think these are 1 microfarad. I think it's ceramic SMD caps. There's a 6812, I think. Correct me if I'm wrong. and we get a resistor, a small resistor to go on the board as well. Yeah, quite a nice little board. How long are we on? We're 5 minutes in. Will we make one? Yeah, I think we will. Okay, bear with me. I'll pause the video, I'll get set up, and then we'll make it. See you in a moment. Okay, dokes, right, that's us set up. So I'm using this little Baku, is that how you pronounce it, whatever, PCB holder. These are very cheap. You get them on AliExpress, places like that. I'll pop a link down below if you want one. And all you do is you pop it in. It's got little sort of cuts in these aluminium sliding parts, if you want to call it that. I don't know what the actual term for it is, but essentially that holds the board in place and allows you to, you know, work on a surface mount board, or indeed a through hole board, you know, without having to stick it down with tape or blue tack, whatever you want. It's really handy, and they're very, very cheap. So what I'm going to do is I'm going to use my good old mechanic solder paste. What one's this? This is XGZ40. Good old tin lead alloy, and yeah, we'll just apply a small amount of solder paste to each of the pads before obviously putting the components on. And I'm going to attempt this board using hot air. I think Sion used a toaster oven to do his, and David Watts, if you're familiar with Dave's channel, he's going to attempt to hand solder his board, and I can tell you right now, David, that is not going to happen. Fair play for trying, but I'm very skeptical if you'll be able to do it. So just using my thumb on the plunger, this might be difficult to get everything in shot, but we're just going to apply the smallest amount of solder paste to each of the pads, and it really doesn't need a lot. Just the tiniest amount. I don't know if you can see how much I'm putting on there. It's not focusing. Yeah, very, very little. So what I'll do, rather than bore you with me squeezing out loads of solder paste, I'll paste up the board, and then we'll come back to you, and then we'll put the components on. So I'll catch you in just a moment. Welcome back. Right, that's the solder paste applied. I redid the ones at the top because I wasn't particularly happy with them, but if I just put that on the side, and if I get it to focus, there is barely any solder paste on that at all. It really is not a lot that's needed for this process. You know, just the slightest amount. If you put too much on, then it's just not gonna do you any favours, to be honest. I've just realised I've smudged one off there, so I'll just reapply that. Like so. And what we're going to do now is actually populate the board. So the first thing I'm going to put on is I'll pop on one of the LEDs now. If I can get this to focus, you will probably just be able to make out at the top left there's a little notch cut in the board. Can you see that? It looks slightly white there. So that is just to get your orientation right. And as we look at these LEDs, you can probably see it a bit better now. They've got that notch at the top left there, and the black sort of die, or whatever you want to call it, is on the left hand side at the sort of 9 o'clock position, and that's the orientation you want it to go on the board. And if you just look at the top left, you'll see there's a little sort of tab coming off the side of the silk screen, and that indicates that that's where the corner goes. So I'm doing this, holding it, so it might be a bit wobbly. All we're going to do is lift it into position and drop it down, and then just give it a gentle nudge. You can give it a little tap if you want, and that'll get it in position. Quite nice. Okay, the next component I'm going to put in is the smaller LED. Now, the smaller LED, it's more difficult to see the orientation. So on here, this is the correct orientation. So again, that little black dot inside the lens is on a 9 o'clock position. However, the notch is at the bottom left in this case, which again you might be able to just make out. And that goes, the notch goes to the bottom left on the PCB here. You can see there's a white mark on the silk screen, bottom left. So that just indicates the orientation. So it's a different pinout, I think, this LED to the previous one, but it's the same process. We're just going to drop it down onto the board, give it a slight nudge into position, and if you want to, give it a little tap down. However, once we're heating this up, the solder should melt and reflow, and surface tension will drag the component into its correct alignment. Next thing I'm going to pop in is the resistor, and it goes at the very top left of the board on those two small pads. Place it on, tap it in, and finally our capacitors, 3, 3 and 3 along the bottom. And just the same process, take it in. Again, don't worry too much if the alignment's slightly out, it will be dragged into alignment. So that's how you put the components on. What I'll do now is I will continue to put them on. Sorry, I should say, it helps if you, I say it helps if you lay them out. I've just knocked them all everywhere. But if you keep them all in the same alignment, it should be a fairly quick process to get them in. Just remember, keep that black die on the left hand side. I should mention, of course, when you get your kit, it may be that Sion's using a different supplier, or whatever. I don't know if the black ones are exactly the same, but always check the pin out, check where that notch is. I don't want to tell you to keep that dot on the left hand side, and the ones that you get sent, that black dot might be at the top or the bottom, or whatever. Just check where that notch is and go with where the notch is rather than where that black dot is, if that makes sense. So I'll pause the video, I'll get the rest of the components on, and then we'll reflow it. Catch you shortly. Right, welcome back yet again. So that is the components on the board. I'm an honest guy. For the second time, because I decided to program my Arduino before reflowing it, so that once I had reflowed it, I could test it straight away, just so I wasn't pulling the wool over your eyes and saying that it was working when it wasn't and all that stuff, because there's always that tendency. So I want it to be a true and accurate reflection of the kit build. And yeah, while I was programming the Arduino, I lifted the USB cable and Arduino across to the side of the desk, and the cable caught the components and swiped half them off the board. And you can probably see down the bottom left there's a bit of residual solder paste there. So yeah, hopefully it should be okay. Where it did look like it had lost some of the paste, I did reapply. I've just noticed that one's I'm shaking here, very slightly out of alignment, so I'll just tweak that very slightly. And yeah, now we're going to reflow. So I'm using my Aten 858D Plus. These are super cheap these days. You can get them on Amazon for about 30 quid, I think. That's where I got mine's. And we'll just bring it up to temperature, and then we'll go in. So apologies if this gets in the way. There's no other way of me really filming this suitably, but bear with me. Now, as always, we want to move the airflow constantly around the board. These, of course, have plastic cases, the LEDs that is, and I don't want to keep the hot air in any one place for any great length of time. I just want to sort of gently bring the board up to temperature, and hopefully the solder paste itself will retain some of that heat better than the plastic, and by moving the airflow around, the solder should melt before the plastic. That's the theory. Let's see if it works. So as you can see, I'm just doing a figure of 8 round the board, so I get all the components equally heated. And you can tell when the solder paste is about to reflow because it goes a sort of lighter colour and gets sucked in under the components. So that's kind of up to temperature, I would imagine. Let's just gently concentrate on a couple of them just now. A couple of rows, that is. You want the airflow fairly low on this because you don't want to blow the components off. So these capacitors on the side look like they're reflowing now. And I think I'm going to have to concentrate the heat a little bit because it doesn't seem to be doing much just now. There we go, cap's reflowing there. And the LEDs are going now. And I'll tell you what, I'll pause. You've seen those ones reflow down there. What I'll do is I'll pause the video, and when I get to the last stage, I'll restart the video just to stop you waiting here. See you in a moment. So that's just the last few to do now. I found actually concentrating heat on the LED and just waving it around a little bit, and as soon as you see it reflow, you know, and drag into position, move it away straight away. I don't think the temperature, I'm using quite reasonably high, 320 on the 858D, reasonably high, but I don't think it's hot enough to damage the LEDs because it's not for a huge amount of time it's been left in place. So I think that is the board complete. Oh, that's bloody hot. Excuse my French. Let's just have a look side on. So yeah, doesn't look too bad. There's no obvious solder paste hanging out the sides. Actually, he says, I don't know if you can see that one at the top right, does look a bit like it does need a bit more heat. So we'll just bring that back in. I say, as always, you're getting it Watson all, guys and girls. I like to be realistic. I'm not an expert, and I know a lot of you guys and girls aren't either, and that's not me being patronising, but you know what I mean. We're hobbyists, and I'm showing you the hobbyist way. Right, that's it now. I think. So we'll let that cool down, and yeah, we'll get ready to solder the header in just for testing. So I don't want to. I mean, there's not a huge amount of heat in this, but I'll get it out of the way. Yeah, nice little board. And they're all, as you can see, they're all nicely aligned. There's none sort of really wonky. This one very slightly a bit askew, but yeah, well, we can deal with that. So next thing to do is put a header pin in. I think I'll try it at that. I'll gently wave it around a second. Obviously, don't do this straight after having put the hot air on it. The solder will solidify very quickly. I'm just getting a bit of cool air onto it just to cool the board down totally. Yeah, that's a bit better. Okay, so we'll pop the header pin in that way. Let gravity do the job. Bring the iron in now. A little bit of solder. And we'll do the centre pin first. Like so. Check for alignment. That's good. In fact, it's not good. That's better. And we will do the 2 pins. Obviously when you're doing this, take care not to melt the adjacent LED there. Alright, let's have a look. Yeah, that looks good enough. So we'll bring in Arduino now. I'm just using one of these DeMillanove, one of the original. This is a genuine Arduino. I got this years ago when Arduino first came on the scene. But yeah, the way we're going to hook it up, we've got 5 volts and ground down here. So what did I put? Yeah, ground's black, 5 volts is grey, and data goes to pin 4, digital pin 4. Now I've downloaded the sketch. You can get all this on Seon, or the Unexpected Makers GitHub. Download the appropriate libraries using the library manager, and yeah, it should work a treat. Just noticed that the power pin isn't soldered very well, so I'll just quickly redo that. Apologies. Iron should still be hot. Yeah, it is. That's better. Right, let's get this show on the road. So what did we say? 5 volts was grey, so put that to the bottom. Next we've got white, which is data, going to pin 4. And it just so happened they both were on at the same time. So there we go, there's a configuration we've got there. So bottom pin going to 5 volts, data pin going to pin 4, and ground to ground. So, fingers crossed, it should, in theory, work. Fingers crossed, no pressure. Let's plug in the Arduino and see what happens. Okay, right, so we do have a problem. Let me just gently press and make sure it's not a broken connection somewhere. So that's doesn't appear that that's the problem. So let me investigate, and I will restart the video. Sorry, I don't know if you can even see that. So the right hand row is illuminated, but that's it. So bear with me one moment and I'll see if I can establish what the problem is. Catch you shortly. Right, well, I've just spoke to Seon, and yeah, not going to beat about the bush. I've cooked these LEDs. My hot air was way too hot. 320 degrees Celsius is what I had. Realistically, it should have been somewhere along the lines of half that, around 160, 180, something like that. So, yeah, take 2. So I tried my solder paste with a lower temperature, as Seon suggested, and it, yeah, didn't work. It's just not going at all. So, and I'm by no means trying to steal Dave Watt's thunder, but I am hand soldering this board, believe it or not, and it is doable. I thought it wouldn't be doable, but it is, I think, just. So I've applied solder paste in the same fashion as before, and as you can see, that's moving around there, and it's just a case of getting in with a really super fine tip. Melt the solder, don't keep the heat too long, and as you can see, that is now fixed there, only by one pad obviously, but yeah, it is doable. So I'm going to attempt to hand solder the entire board, and then we'll come back and test it. Bear with me yet again. So, it's some time later. I've hand soldered, yes, hand soldered this board, and I had exactly the same problem. And I went online, had a chat with Sion, he was online, and said, "Look, mate, I've resoldered it, hand soldered it, and I make exactly the same problem." Given the fact that I thought I'd really super overheated that board, I thought I agreed with Sion. I thought I'd cooked it. So I tried the hand soldered one, exactly the same problem. So if you remember, it was 7 green LEDs up the side, and the top one was a yellowy tinge, almost as if I had overheated it. But this one, it was absolutely identical. So he just suggested I try the Neo, what is it called? Let me see. Strand test, and just say it's got 29 neopixels. And if I plug it in, you will see that the one I thought I'd cooked is working absolutely perfectly, as is the hand soldered one. And just to prove that it is actually working, in fact, I'm going to have to do this just to show Dave what's. Let me get a bit ahead, because I just stuck the pins into it. Now I had a short, so I had to take off the caps, so there's a few of the caps missing, but we'll stick the what do you call it, header on that anyway, and it should work without them. Well, it did a moment ago, so let's see. Oh, loads of solder on that. Granted, this one does have a couple of casualty marks, a couple of injuries. A little, if it's going to focus. Probably not, yeah, I caught a couple of them, but never mind, these things happen. So if I unplug that board, this is a hand soldered one. Well, it's not fully soldered, as you can see. I've obviously missed a few on there, or it might be to do with the caps. Yeah, but I'll finish off hand soldering this one, and yeah, we'll call it a day at that. But there we go. Eventually, what's and all, as always, there is our working Neo 7 segment display from Unexpected Maker, Sion. So, I'm expecting to get quite a few thumbs down for that. I'm going to upload it. It was not a problem with the kit or anything. It was me and my rubbish coding. Coding is not my forte, but it is working, as you can see. So thank you very much once again for watching. Hopefully enjoyed that, seeing me fail and trip up and having to fault find again. But yeah, it's working. Thanks again. Thumbs up if you enjoyed it, thumbs down if you didn't. Either or, don't worry about it. As long as you do one, that's fine. Any comments, obviously pop them down below. And until next time, as always, take care of yourselves and all the best. Oh, and subscribe if you haven't already done so, and you'd like to do so. Ta-ta.